Castigate.
Okay.
Like a movie. It's Tegan and Sarah.
I've heard it was amazing from everybody else but you.
No, I meant the
Variance. Normal?
Well, what's normal?
Is that hard? Can we make it shorter? Because it's really hard to write.
More than a page?
Yeah, more than a page.
Front and back, or like?
Shortcut.
It's really hard to do. Come on.
Well, it's a little bit zoomed in. Let me zoom that out a little bit. Okay, shortcut. Let's quickly review the symbols, because it's all about symbols here on the calculator. Population variance. Do you remember what the symbol was? It was a Greek letter.
This is sigma, lowercase sigma.
Lowercase sigma squared. This one you will not find on the calculator. It's not on the calculator. Because that's that useless one with those squared units. But we do a lot of math with it. But population standard deviation is on the calculator. What is its symbol?
Sigma.
Just sigma. So, this one will be on the calculator, but if the book asks for the variance, what are you going to do since the variance is not on the calculator? You're just going to take this answer and square it. Because you're smart. We got to figure it out. Patience. You have to know the symbols first before we get to the shortcut. Sample variance. What was that symbol? That was S squared.
Did you remember?
Again, this one is not on the calculator.
Is it capital?
It can be either. No. So then sample standard deviation is just going to be S. Okay. On the calculator, we are going to still have to put the numbers in a list. Enter values in a list. And then quit. Then the magic happens when you go, the programmers did a lot of nice programming on this one bar stats button. You're going to go under stats. You're going to arrow over to calc, which stands for calculate. And the number one button on there, because it's used most often, is called one var stats. Var stands for variable. One var stats. And then you can put a list number. The list number is not necessary. If you don't put a list number, the calculator automatically goes back to list 1 and works with that one. So if you put your numbers in list 2, you've got to tell it list 2 or list 3. If you don't put a list number, it goes right back to list 1. So let's try. Find the variance and standard deviation. And let's do that number 11 that I had up here. I'll put it up and you won't need your book open. So the number 11. So grab a calculator. Put the values for number 11 in a list. I've already got mine done. 79.
11.
Number 11. So put them in a list, hit quit, and then we'll do the rest of it together.
What page is it again?
79.
I know what the mode is.
You know what's the mode? I don't want the mode. The mode's dumb.
Hey. did a problem. I deserved 10%.
Are we ready yet?
No.
No. Emily said no.
I'm failing. I think I did before. I can't feel anything.
Ready? Okay, press your stat key. See that?
Go.
On the top row, you see edit, calc, and test. We are going to be doing the test in another chapter, but for now, we're going over to calc. Over to calc. 1 bar stat. See right below there, 2 bar stat? Never, ever, ever, ever touch that button in this class.
Why?
We don't do 2 variable stats. It's in another stats class beyond this one. So never should you have to ask me, what's that 2 bar stat? Am I using that? No. 1 bar stat is it. Keep it simple. So press your 1 bar stat. Because they're in list 1, at least mine, I don't have to put a list number. If they're in list 2,
Why is mine creepy?
1 bar stat?
Mine's a big-
Oh, because you guys have something, you got newer operating system. As long as you got the list number and the frequency's 1, you're good to go.
You're good.
Oh yeah, I forgot about your new operating system, people.
We have to put
Frequency's always 1. Always 1.
Well, that turns out why.
We don't have to put one. We put it with one.
And then hit enter. I don't know your new operating system.
I don't know why.
Error.
Yay!
Can you guys not? I will collect them.
Have you ever seen Adventure Time? Have you ever seen the root beer guy? Adventure.
Don't put in 1 for
Why, yeah. But it's error.
I have to call them and go to his house.
Put number 1 in. Is everybody good? Yep, calculation.
Get over together and we'll go see it. Except Kelsey can't help.
Okay.
Wait, what? What?
All right, let's talk about what's on the screen. Guys, pay attention. There's a ton of information here. Because see the little arrow down? There's still more information than what we've got. X bar is the first thing. What is X bar?
Mean.
That's the average of the list. Okay? What's the second thing where it says sigma X?
The total of all of them.
What does sigma mean again?
Total, add all up.
Add up the X, because it added up all the numbers in the list. Do I need that? No, but it's there in case I do. The next one says sigma X squared. What's that do?
Square them all.
Squared them all, then what? Added them up. I don't need that either. Next one is, what does that look like?
The
What does that thing look
sample
like?
variance.
X with an X. What do you think that is?
Sample variance.
No, wouldn't that be, sample deviation? Sample.
It is
deviation.
sample,
Yeah.
standard deviation, because it's an S. Does that make sense? What's the next one below that?
Population standard deviation.
That's the population standard deviation, sigma X. They throw a little X next to it because that's the variable that they call it is X, but we don't have to put that there. So, there's your sample standard deviation and your population standard deviation. Does the calculator know whether you put in a sample or a population?
No.
That's why it calculates both of them. It knows you, the operator, are going to pick one of those two. So it does both of them for you. Okay? Next says n equals 14. What's that?
Number of.
How many values are in the list. Arrow down. See what other information it gives us. What's next?
Wow.
Minimum. That's sometimes helpful.
What's Q1?
Q1, you're going to know that in the last, I'm not going to tell you right now, but you will know what that is by going into the chapter. Median.
Then max.
Q3, you'll know that later. And max. There's a lot of nice information the programmers at Texas Instruments put into 1 bar stats for us. Why did they do what? The mean's the very first thing. Yes, the mean's the X bar. Okay. They did a great job. We're going to use that a lot this whole semester. So, how do I know which standard deviation to take for problem number 11? Do I want the X or do I want the sigma?
Sigma.
Why the sigma?
It says population in the question.
It's got to tell you, population data set, it's not a guess, so we want the sigma one. So, I know the standard deviation, what was it? I can't see it.
3.2.
20, good enough. That's the standard deviation. How do I get the variance?
Square it.
I got to square it. What's 3.20 squared? 10 point something
10.24.
is my variance. So when the question asks for variance, you've got to know what to do. Variance is not on that calculator. Okay, so that was our nice shortcut. Next, interpreting the standard deviation.
I like this.
You don't know what thing and accidentally made this fucking walking pot like no, like the sport curling.
Estimate the standard deviation of the set here that I give you. And start simple. I'm going to give you a frequency distribution. Frequency. Okay. What did my data set consist of before I turned it into a histogram?
Numbers.
Exactly what, according to my graph?
5.
Do you agree with Dylan that it was 10, 5 listed out? 5, 5, 5, 5, and I had 10 of them? Is that what this graph is showing? I think so. Okay. So what is the average of 10, 5?
5.
I would hope it's 5. That mu is the population mean versus sample mean, but the formula to find a mean is always the same no matter if I've got a population or a sample. Just the symbol is different. Okay? Standard deviation is the average distance away from the mean. How far away are my 10 values from the mean?
0.
0. So the standard deviation here would be 0. A 0 standard deviation means I'm not away from the mean at all. They're all sitting right on top of the mean. There's no distance away. Does that make sense? Kind of. Okay, that was an easy one. Let's go for another one here. Let's go with 2, 3, 4, 5, 6, 7, and 8. Let's say I have a few 2s and a same amount of 8. And I've got a couple of 3s and a couple of 7s, same amount. I'm not even going to tell you how many of each I have. It's not important. Any guesses as to what the mean of this data set would be?
5.
Why?
Because it's completely equal on every side. And
That's
5's right.
symmetrical. 5's right in the middle. Does that make sense? If I added my 3's and 7's together, what would I get? 10s, and I divide by the 2 groups. 8's and 2's added together, I get 10s, divide by the 2 groups. So yes, I do have an average right down the middle. The average is 5. Now I want a rough estimate of the standard deviation. Well, how far away are the 7's from the mean?
2.
Because they are 2 away from the mean. So the S here would be, not S, but the sigma. Sigma would be 2. How far away are the 3's? 2 away. The 7's are 2 above, the 3's are 2 below, but the distance is still 2. How far away are the 8's? 3 away. How far away are the 2's?
3.
If I was to average a bunch of 2's and 3's together, what would I get?
2.5.
2 point something? Agree with that? It's 2 point something. It's not going to be over 3. It's not going to be under 2. Would it be closer to the 2 or the 3, do you think?
2.5.
Closer to the 3 because I've got more of these. There's more that are 3 away than there are that are 2 away.
I should